Okay, let's start this lab the same way we always do. We'll connect to the server and let's pick up file. And right there, inside classes, we'll see inside geometry, and we've got it right there. Drag, make a copy of that onto your desktop. That's right. And at this point, you could close this connection. It doesn't need to be open. And before you do anything, change the name, NAME. Change it to your actual name. If my name was Fred Flintstone, I might type that in. I have to spell it correctly. And then you can open up the file. And you've already have it named. Let's go. All right, we're on the first page now, and this is just a bunch of definitions, and this is sketching. I don't want you wasting a lot of time on this. Let's just draw some pictures. Take our circle tool, draw a random circle. Well, I guess that would be a circle. You'll have to go to your pointer, and you can move some of the captions over. We're going to draw a bunch of these things. I'm going to draw from the center to that random point, and I know what I created right there because that is the radius. So just drag that over. We made a radius. And we could try something else. Maybe I'm going to take a segment from here to here. That segment has its endpoints on the circle, and that's going to be a chord. Now I want to make a drawing of a chord that passes through the center. We have another name for it. I'm going to put a random point here. Go back to select. Activate the center as a center of rotation, select our point, and from the transform menu we're going to rotate 180 degrees. And that will give us the diameter. So again, quick definitions just to refresh our memory. And we know that this circle's center is over here. We have a couple more objects, a couple more things here. Imagine I've got this line. It can intersect in two places, 0, or one place. If this circle were a wheel rolling on the ground, touching in one spot, that would be its tangent. Over here with the red line, if it intersects in two spots, that's going to be the secant. And what came up during class, what's the difference between the chord and the secant? Well, one is clearly a segment. We have a segment and we have a line. The only other definition we had was concentric. So anywhere on your paper or on your page, draw two circles with a common origin, and the two circles are concentric. All right, that's the easy page. Let's move on. All right, now click to page 2, and you'll see that over here on the tab, Theorem 10.1. And I've made this little figure for you. Not a whole lot to do here. If I move it around, I see this action where this point M, this is the tangent, and it's perpendicular to the radius at the point of tangency. So you see point P would be the point of tangency, the one point where it touches the circle, and of course we've got that perpendicular line. But you know, if this class is going to be fun, you're going to have to do a little more than that. So let's, you're going to construct a tangent, right? Here we go. Draw a random circle. Now you can label points. You can do this without labeling points, but I'm going to label them for the purpose of instruction. I'll say the center is that little R and this point S. So I define the circle with RS. Now I want you to put a random point, another random point on there. When I define that one, that is T. Notice, point T is restricted in travel just to go around the circle because you did not identify the circle. That's not how you built it. I'm going to draw the radius RT. Now if I draw the radius RT, remember S changes the size of the circle, T just rotates. And we're going to construct the tangent. So I need a line that is perpendicular. I guess I'll select the radius, the point T. I'm going to go to the construct menu and construct a perpendicular line. And let's make it, oh, red's a good color. And we'll have a little fun with this. Let's animate this just for fun. I want you to select the point T. We're going to go to the Edit button, Action, Animation. And you can let it go clockwise, counterclockwise. Select a speed. I like speed 3. It's kind of fast. And let's make this one go clockwise. I hit OK. And I should have had a, oh, there it is, a button generated. And this will spin the point around like this. Now, one more thing you can do to make it interesting, just for fun, let's select this tangent and go to Display, and you may trace perpendicular line. You can use the soft command Apple T or Command T, but that may not always work if you're on a different version of sketchpad. And when you trace it, you get this. Oh, that's a lot of fun. So make sure you get that done before you send it in. I can clear them, start again. We're going to be doing a lot of this. This is a tough chapter. We might as well make it fun. All right, next page. All right, we're on the next page, the externally tangent circles. So we're going to represent this a couple ways. We'll do this on a graph, and then we'll do this free. And let's start. I asked you here to make a red circle A and a blue circle B to be externally tangent. And let's make a happy little snowman out of that. If I were to start, I'm going to put a, well, that would be a silly snowman. Let's start maybe here. And I'll change that display to red. And I'll make that circle A. Up D. So we'll make circle A. Maybe make that red too. Now, for my placement, where I'm going to place the next circle, I want to align the circle vertically like this, because I want to stack these snowballs up so they don't slide off. And I'm going to make this not E, but I'm going to make this point B. I'm going to make this point B, and then I'm going to take my circle and I'm going to draw it so it just snaps to this point right here. And I'll change that color to blue because that's my blue circle. So there you go. I've got my two circles. They are externally tangent. We know that in each case, the distance between these centers is going to serve as the radius, and it must be perpendicular to the tangent at the point of tangency. So that would be this line right here, which would be y equals 10, would be the common tangent. So let's go ahead and make that this color, display line with thick. And there you go. This is the common tangent, and the two circles are externally tangent. All right, but I know you want to do something fun, and you have to. We're going to draw a random circle. Now, I don't care what color it is. It comes up blue, that's fine. Same thing we did before. This point is just for sizing, and I'll place another point here. And I'll label just that point this time, and it comes up F. Now, I'm going to dilate. I want to double click on the center here. I'm going to dilate F, transform. I'm going to dilate by a factor of, oh, let's say 10 to 7. So that's going to push it farther away. And if you notice, if I were to line these up, F, this new point, and the center, of course, collinear because it's a dilation. So I'm going to now draw another circle. Now let's make this one magenta on the outside right there. So from this point, snapping here, and I'll make it, I'll pick a different fun color, and we're going to do a similar thing as we did last time. Let's make an interesting shape here. I'm going to animate point F, action, animate. We'll go counterclockwise this time. I like to go a reasonable speed, so we'll go 3 or fast. And we're going to set, well, and see where, oh, I don't know where my animate button went. Oh, there it is. And I will set my circle display, trace the circle, and there it goes. Whee, this is fun. All right, so now you're done with page 3. let's move on. All right, next page on the bottom tab here, internally tangent. We're going to draw circles C and D so that they are internally tangent. And we'll just pick a arbitrary circle here. Oh, that's kind of thin, so we'll make that one a little bit thicker, and we colored this one green. Why? Just so we keep track of them. And we'll call this circle C, not E. We're going with C. And let's keep our color scheme all nice. Now, for the coordinate plane, it's easy to see if we stick to cardinal headings. We went up and down before. Imagine north, south, east, west. Let's go to the east. If I go this direction, which represents a radius, somewhere along here, I could choose to be the center of another circle that I could snap to this common point right here. I'll make that circle magenta, and you're going to call that one circle D. And there it is. So that's our commonly internal tangent circles. Oh, and the tangent that is common to both of them is right here. It looks like x equals 16. And let's make that line stand out. And you should put the equation of the line there. So that's the equation of the line that forms the common tangent. So here we go. Let's make a dynamic figure, drawing a random circle like we did before. This one sets the size, and I'm going to put a random point on the circle right there. And this time I'm going to dilate inward. I like this number, transform, dilate. We've been doing it this way in class all day. Let's dilate 7 to 10. And this time we're going to draw the circle from here to here. Let's make that any color you want, as long as it rhymes with door hinge. There you go. We can animate either of these 2 points, this one or this one. Edit, action button, animate, and that's, I guess it's over there. And trace, and we're done. Let's trace circle. Ready, set, go. Well done. Oh, that's kind of slow. Change the properties if you want. Other, for, and there's our slinky circle right there. Lots of fun. We can change the traces at any time. Gives it a three-dimensional look. Next page. Well, we're about halfway through the lab, and you can see right here we're going to construct the common internal tangent. And all we're given is the line AB. So, first thing we're going to do, we'll do a little bit of rotations. You'll see why in a little bit. I want you to identify B as the center of rotation. Take that segment in between, AB, transform, rotate it 90 degrees. It'll rotate 90 because that's the default. Select A for the axis or center of rotation and rotate the same piece. So now you can see the piece that you've made right there. It will vary if you move the figure around. Now A and B are going to be the points of tangency, not the centers of the circle. So in your tool, put the little right angle in there, click, 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 1, 2, 3. You've done this many times before, 1, 2, 3. That gives you the perpendicular marks. Right here, this is just going to be the position of our circle. Random point, snap to A. Random point, snap to B. I'm going to hide these 2 segments now so I can resize my circle, and I will draw in the various radii. And radii in class, we made them red. The red radii. And there you have it. AB is a common internal tangent. But we made some analyses, some pictures, we made some conclusions. Let's draw this. Let's draw, let's pick another color, magenta, and we'll just say observations. Some of the more exciting observations in class. Well, AB must cross this magenta line. if I change the size of the circles cannot intersect. Another interesting observation. Another very interesting observation is this one. Let's look at this triangle right here, and then I want to look at this triangle. Now we know we've got vertical angles, so they are certainly not congruent because I can change the size dramatically, but something that I did want you to know is that triangles, we have similar triangles, and you can use the symbology. Similar triangles by angle. That may come in handy solving a future problem. All right, we're done with this page. Let's move on to the common external tangent. Now here what we've got is the same, well, similar to the last page, common external tangent. Now I want to clarify that it's not the same as this. Remember we did this on a previous page. Those were two circles that were externally tangent to each other. That's not what we're doing here. Instead, what we're going to do is construct two circles that share this tangent. And we'll make some observations about them. Same thing. I'm going to double click to identify B as the center of rotation. Rotate this segment. I'm going to rotate the segment. Comes up 90 degrees default. That's great. This time, when I rotate around A, and I go to my rotate, I don't want 90. I want negative 90, also known as 270. And now you can see they're on the same side. And we'll keep this going. Draw a circle here and a circle here. Centered random points on the segment. I forgot to put my right angle symbols in, but it's never too late. My right angles, 1, 2, 3, 1, 2, 3. Now let's hide these. And we're going to replace these with our red radii. Just like the way that sounds, red radii. And now we have two circles with a common external tangent. Observations? Well, if I connect these segments here, might look like a rectangle, but it's clearly not. Great observations in the class. Yes, this is a trapezoid. Also, notice that these circles, the circles don't overlap. They can be tangent, and they can intersect like this. So there's a variety of shapes that can be had. We're going to need this for a future problem. So make sure you got this somewhere in your notes because we'll be doing a calculation based on a figure that looks a lot like this. Remember, the right angles are up here. And I think we're done. Let's move on to the next one. We're making some progress. And now getting close to the end with a theorem, Theorem 10.2, saying tangent segments to a common external point are congruent. So this picture, we're saying these two segments meeting at the common point S are congruent. And we haven't done a proof in a while, so you're going to do a proof visually. I've got a little button for you there. Well, that's radii. By definition, the radii are perpendicular, I should say by Theorem 10.1, perpendicular to the radius at the point of tangency. So, if I were to draw this right here, you all would recognize that. Say, I can connect any 2 points with a unique line, ray, or segment. I know that is congruent to itself by the reflexive property. There you go. Given that the two radii of the circle are congruent, I've got these tick marks. So we're going to solve this without even doing any. And without writing the proof, we'll just solve it visually. Let's construct a triangle interior there. And so we can visualize that when I reflect this, that I get, or my two triangles are congruent because I get a complete overlap. Maybe change the color on one of them. I like if you use the palette so you can get lighter colors. So you can still see your work there. And all that's left is determine why the triangles are congruent. And I guess we would say triangle right there. Put that down, PRS. That's PRS. And we're going to say is congruent to triangle PTS, PTS, and you've guessed it. I've got two right triangles, PS the hypotenuse, this is the leg, and we'll say by HL. Once we got that, we're done. By corresponding parts of congruent triangles, this is taking you way back to chapter 4? Then the two or remaining corresponding parts are congruent, therefore PS is congruent to TS. And we've proven it. Well done, that's our only proof, and we've got one more, and then you're done. Last page, yahoo! Well, you'll see this problem a couple times in our chapter, and what we're trying to do is solve for a radius here of this given circle, given that it has this tangent segment with a length of 15. Now, very conveniently forming a right triangle for us. So let's see what we can do. We'll start by taking this, the given Pythagorean theorem, and remember, if you select the caption, Command C, Command V, that's going to make a copy of it. And let's do our substitution. It's up to you if you want to keep notes here. I like to do it. So if you want to say substitution, so if you type in substitution, replace that, and we're going to substitute. As we said in class, a good pirate would say R. We'll make that R, and that's going to make B equal to 15. And then C. Well, C is going to be a combination of the red piece and the black, and we'll say that that is the sum of R plus 9. That completes the substitution. Next, make a copy and paste, and let's evaluate a little. You should have memorized from before that this is 225, and now you've got what we're going to have to do is evaluate or simplify, and we're going to expand this. If you don't already know, this is a perfect square trinomial. So first term would be R squared. And let's see where my cursor is. And I'm going to add to that. I know the last term's 81, but the middle term is twice the product of the two terms. 9 times R is 9R. Twice that is 18R plus 81. Well, make a copy of that. And let's do the simplify. Keep track of this, or I could say, how about subtract? Even more appropriate. I see I've got an R squared on both sides of the equation, right there. From here, subtract again. I've got an 81 on both sides of the equation. 81, and that'd be 144. And clearly, all I've got to do now is divide. When I divide right side by 18R by 18, I get R, and here I would get 8. And what do you know? The radius must be equal to 8. Of course, if you looked at this, you would see that 8 plus 9 is 17, and this is simply an 8, 15, 17 Pythagorean triple. All right, you're done. Let's get this thing finished and send it into the Dropbox. Congratulations.